Welcome. We are going to do more examples of calculating partial derivatives. Our next example is a good test of your understanding. This asks for the partial derivatives of the function x power y. Remember that when we are doing derivatives, you cannot just look at the form of the expression, but you have to look at where the variable is. And in partial derivatives, you have to remember which we are treating as a variable and which we are treating as a constant. If I'm differentiating with respect to x, I pretend that only x is changing, y is staying constant. So if I have x power y, it's x to a constant power. So it's like x cubed or x power pi or x power e. If I have a variable to a constant power, I use the power rule. So to find the partial derivative of x power y with respect to x, I use the power rule. So I get the old exponent y times x to the power y minus 1. But when I do the partial derivative with respect to y, I pretend that it is x that's constant, y is the variable. So x power y is like 2 power y, or 5 power y, or pi power y, so on. So I have a constant base and the variable in the exponent. In this case, I have to use the rule for exponentials. Remember, this is the general exponential, where the base is not necessarily e. And the rule says you get the exponential times ln of the base times derivative of the exponent. So in this case, I get x power y times ln of the base, ln of x, times the derivative of the exponent. The exponent is y, its derivative with respect to y is 1. So the partial derivative with respect to y is just x power y ln x. For our fourth example, we are going to do a function that involves logarithms. This time I have three variables. If I'm differentiating with respect to z, I pretend all other variables are constant. So I treat x and y as if they are constant when I do this calculation. The function is a product. The first factor is xy plus yz plus zx. The second factor is ln of x squared plus y squared plus z squared. Since I have a product, I have to use the product rule. I differentiate the first factor with respect to z. In that factor, I have three terms. The first term has no z in it, just x and y. So I treat that as if it's a constant. If x and y are constant, then x times y is also a constant. Its derivative with respect to z is 0. In the second term, I have plus yz. So it's like I have a constant factor y times z. The derivative is a constant factor times derivative of z with respect to z, which is 1, so I just get plus y. Similarly, in the third term, I have plus zx, so it's z times a constant factor x. The partial with respect to z is the derivative of z with respect to z, which is just 1, times a constant factor x, so I get plus 1 times x, which is just x. So times the original second factor plus the original first factor times derivative of the second factor. Now I have to use the chain rule. First I differentiate for the outside. The outside is ln. When I differentiate ln, I get the reciprocal of what's inside times derivative of the inside. The inside is x squared plus y squared plus z squared. I'm differentiating with respect to z, which means I treat x and y as if they are constants. In the first term, I have x squared. So if x is constant, so is x squared. Derivative of constant is 0, so I get 0 from the first term. For the same reason, I get 0 from the second term. In the third term, I have z squared. The derivative with respect to z is just 2z. So for the inside, I get 0 plus 2z. Of course, we can write this in a simplified form, even though it's not really necessary.